Hey, Algebra 1, here we are, and we're in section 11.5, and we're going to be talking about the distance formula today. The cool thing about the distance formula is that it is totally connected to what we learned, the Pythagorean theorem. If you remember, last time we talked about the Pythagorean theorem, and that was a squared plus b squared equals c squared. The reason why I gratuitously showed you this little bit of a picture snapshot of a really nice YouTuber is because I really like this guy. And if you felt uncomfortable about Pythagorean theorem, I would really suggest you go to YouTube, check out Math Antics. I think his name is Rob. He always does a really thorough explanation. It's a little corny, but you know, I like corny things, so it's totally right up my alley, and I think it'll be up yours too. But a squared plus b squared equals c squared is what we are working on, and that's the principal idea for what we're going to talk about today. So how does this crazy looking formula that looks mad complicated relate to the Pythagorean theorem? So here's what I'm going to do. I'm going to draw an xy axis or coordinate plane here, and I'm going to put some points down. And so what the distance formula is going to do, it's going to give us a way to find the distance between 2 points. Let's say this point is 2, 3, and let's say this point over here is, I don't know, for me, I make it simple for myself. I'm trying to think, child. 6 and 6, 6x, let's call that. I'm doing it just so the math comes out nice. All right, so here's what we would do. Now, you can't just go, oh, let me see, I'm going to count the diagonal square lines because that's not going to be the same length as the horizontal and vertical movement, right? And I'm not going to go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. That's not really the distance we're talking about. The distance we're talking about is here. How do you find that distance? Well, if you look carefully, you will notice, keep looking, keep looking, keep looking. You'll notice that there is really a right triangle here, right? And the distance that we search for is the hypotenuse. So how the distance formula works is that we consider this length from here to here, the horizontal length from point to point, the vertical length from point to point. And so the horizontal length here, this would be 6, so that's 4. And the vertical length here, this is 3, so it goes up, boom, 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 3. And you know that this has to be 5 because we've been working on Pythagorean triples. So how would we do that if it weren't a Pythagorean triple? Well, we would say, well, 3 squared plus 4 squared is equal to, remember we don't know this, d squared, right? That's the distance squared. And so how would I calculate the distance? Let me come over here. I'd say, well, d is equal to the square root of 3 squared plus 4 squared. You get it? So you're kind of seeing why this might come out, why we might have d is equal to the square root of something. Let's go over to the generic situation and kind of think about it a little bit differently. So this generic situation uses x sub 1, y sub 1, x sub 2, y sub 2, but the idea is still the same. In order to find that length, we're going to use this idea of a right triangle associated with that, and we're going to use that length as the hypotenuse. So d would be the hypotenuse, right? That's the distance. That's what we're looking for. And to find the horizontal distance, we have to find the difference between the x terms. So the distance from here to here would be x sub 2 minus x sub 1. And the distance from here to here would be y sub 2 minus y sub 1. Does that make sense? So we've got the horizontal distance and the vertical distance, and this is like a squared plus b squared equals c squared, right? Or the difference between the x's squared plus the difference between the y's squared equals d squared. And you know how this is going to go. We're going to take the square root of both sides. D is equal to the square root of all of this stuff right here, everything on the left side, right? And so that's where the distance formula comes from. Oh, lost my square. So that's this. These are the same things. So it comes directly from the Pythagorean theorem. And so we're going to use the distance formula in this section to find the distance between 2 points. So here we go. Find the distance between 2 points. Hey, you don't have to draw the graph. We have a formula that does everything for us. So now that we know where the formula comes from, I feel confident to write it down to use it. X sub 2 minus x sub 1, quantity squared, plus y sub 2 minus y sub 1. So I'm going to find the difference between my x's. Let's call this 0.2. Let's call this 0.1. So to find the distance between these 2 points, I'm going to do negative 4 minus 2 quantity squared plus 6 minus 3 quantity squared. You see what we did there? All right. And so now, negative 4 minus 2 is a negative 6. Negative 6 squared is a positive 36. 6 minus 3 is 3. 3 squared is 9. So when I add 36 plus 9, I get that the distance between those 2 points would be the square root of 45. And I can write that down by taking the square root of 9, looking at this as the square root of 9 times the square root of 5, and I end up with 3 root 5. So the distance between these points is 3 root 5 units. And of course, I can calculate that using a calculator to get an approximate value, which is 6.7 units. All right, that's our approximate value. I'm going to move on to example 3. I think this would be more beneficial for us. So we can also use the distance formula to find information about a point. So we're going to find the value of A if the distance between these 2 points, 7, 5, and A negative 3, is 10 units. So remembering the distance formula, it's always helpful to rewrite a formula every time you do a problem. It helps you memorize it, helps it stick with you. X sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. All right, so now let's call this 0.1 and 0.2 if you'd like. And now what we're going to do is use this information, plug it in, and see if we can solve. So I'm going to plug 10 in for the distance, and then I'll write it like this. A minus 7 quantity squared plus negative 3 minus 5 quantity squared, square root will equal 10. Well, you know from last time when we were working with not quadratic but radical equations, we need to square both sides once we can isolate the radical, which it is isolated, and so we get a minus 7 quantity squared plus, now negative 3 minus 5 is going to give me a negative 8, and that's going to also turn into a positive 64 if I square it. So what I'll do is I'll subtract 64 from both sides to isolate this business here. And when I do that, I get 36 is equal to a minus 7 quantity squared. Now what? What do we do here? How do we solve this? Well, a couple ways we can do this. We could FOIL this out and see if we can factor and do some fancy things. But remember, this is kind of like the square root method. A minus 7, you can take the square root of both sides. A minus 7, the square root of a minus 7 and the square root of 36 is going to give me 6, well, really plus or minus 6. And I'm going to get a minus 7 over here, right? Remember how we did that before? Get the plus or minus the value. All right, so now a is equal to 7 plus or minus 6. Well, a could either be equal to 13 or a is equal to 1. So a being able to have two different values informs us that, and it makes a good amount of sense. So a could be 13, negative 3, or a could be 7, or a could be 1, negative 3. Which kind of makes sense because if you have 0.75, let's say 0.75 is somewhere here, and then you have 0.13, negative 3, and 1, negative 3, it makes sense that they both could be 10 units apart, right? That kind of makes sense. And if you want to, you can graph it and kind of get a visual on it for yourself. Okay, I kind of wanted to graph it better myself, and I thought, let's use Desmos. Let's use Desmos. All right, so we're going to do that. And look at that. Yay. So you see that the 2 points do work. So the a value, there are two a values for that, 13 and 1. And we get, like, you can see that that's equal in distance. All right, sweet peas, that's all I got for you today. I think that I'm going to end the video there. Let me know if you have any questions. If you want to do some extra practice problems, we can do that as well. Let me know if there's anything we can discuss. And for you, you got the distance formula under your belt. Excellent job, guys. Take care.